Let's start with fans, and please focus on this example due to its importance. Here is a video showing how a pressurization fan works during a fire. For your information, the blue circles represent the air. As you can see, the fan starts working when the fire begins. So why does it start working? To push the fire away from the emergency staircase by increasing the pressure. This fan is called a pressurization fan. Fan components, points. Most fans consist of these components, which are connected to the BMS system. Fan motor, VFD, variable frequency drive, DPS, differential pressure switch, DPT, differential pressure transmitter. Let's watch the video about the fan motor. As you can see, when the motor spins, it rotates the fan through a belt. Now, let's watch the VFD video. The higher the frequency, the faster the fan speed. This is widely used in negative pressure rooms in hospitals to maintain a certain pressure level as mentioned in the previous example. Here is the DBS video. Its mechanism is simple. It consists of a positive and a negative tube, measuring the difference between them. When the difference reaches the set value on the DBS, the device sends a signal indicating there is an airflow in the fan. Now the DBT video. It works similarly to the DBS, but differs by sending a signal indicating the current pressure difference. For example, 100 pascals or 400 pascals. In contrast, the DBS only alerts if the pressure difference exceeds a set value. The fan motor points are controlled through a panel called MCC. This panel operates the motor, and its points are as follows. On-off command, DO. This point commands the fan to start or stop. It is a digital output point from the BMS system. Auto status, DI. This point indicates that the fan is in an automatic mode and ready to be controlled by the BMS. It is a digital input point to the BMS. Hand status, DI. This point indicates that the fan is in manual mode. It is a digital input point to the BMS. On-off status, DI. This point indicates whether the fan is currently running. It is a digital input point to the BMS. Why do we need to know the current status of the fan? We know that the fan operates in two modes, automatic and manual. In the automatic mode, if we command the fan to operate through the BMS and the power in the panel is off, the fan won't operate. We would not be aware of this without this point. The BMS operator must inform the fan maintenance team to fix this issue. In a manual mode, it indicates whether the fan has started after being set to manual. Trip status, DI. This point indicates that the fan has drawn more power than allowed, triggering the overload device to stop the fan and send a trip signal to the BMS. It is a digital input point to the BMS. The mentioned points are usually required for fans, but some fans also have a VFD inside the MCC, which adds the following points. VFD speed command, AO. This point commands the fan to operate at a certain speed. It is an analog output point from the BMS. 0 to 10 volt DC indicates that the output from the BMS is within these values, where 10 volt DC means 100% speed and 7 volt DC means 70%, and so on. VFD speed feedback, AI. This point reads the current speed of the fan. It is an analog input point to the BMS. 0 to 10 volt DC or 4 to 20 milliampere. Indicates that the input to the BMS is either in volt DC or milliampere. Notice that the last 2 points are analog and not digital because they provide multiple values. whereas digital provides only two values, such as on or off. TPS point, airflow status, DI. This point indicates that there is an airflow on the fan. It is a digital input point to the BMS. The main purpose of this point is to detect if the belt connecting the motor and the fan is broken. TPT point, differential pressure sensor reading. This point reads the current pressure difference. It is an analog input point to the BMS. 0 to 10 volt DC or 4 to 20 milliampere is the reading method, as mentioned earlier. We have finished this example, and here we come to the end of the free video. I hope everyone has benefited and found the explanation method to be satisfactory. Please click on the link in the description to join the full course. The course fee is nominal. I would be honored to have you all. Thanks for